to look at double and half angle identities. These are identities that you do need to know. So remember, the only ones that you don't need to memorize are the sum and difference formulas. In the notes that you're watching online, we're going to look at the formulas. We're going to look at how to use them to do proofs and how to use them to do calculations. And then when you guys come back to class, we are going to talk about why they work. So you can try to think ahead of time of why they work. You're going to have a discussion in your group when you come back, and we're going to prove them, and then we're going to work on problems with them. So the double angle identities, they say if I have an angle that is, I think of the angle instead of theta as 2 theta, meaning it's 2 times some number. So for example, if the number that they wrote right here was 150, instead of thinking of it as 150, I can think of it as 2 times 75. Now that might not be helpful in this case because I don't really know anything about 75. Okay? So some different things like that. Now, the cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Don't confuse that with your Pythagorean identity. But if we use the Pythagorean identity for substitution, cosine squared theta minus sine squared theta can turn into 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta, and we will see how to do that in a little bit. The sine of 2 theta is equal to 2 times sine theta times cosine theta. And the tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. Now, half angle identities are the same thing. Let's say they wanted you to find something out about 300. Rather than thinking of it as 300, you might think of it as 600 divided by 2. So there's a number here, but you're going to rewrite it as something divided by 2. The cosine of that would be equal to plus or minus 1 plus cosine theta over 2. Now the plus or minus doesn't need both. You need to determine this based on location. So depending on where the angle is, you will determine whether the answer is positive, negative. This does not mean both. Okay? The sine of half of an angle is going to be equal to positive or negative square root of 1 minus cosine theta over 2. And again, that plus or minus is based on the location. It's not both. Okay? And the tangent of the half angle will be equal to plus or minus 1 minus cosine theta over 1 plus cosine theta. And again, that plus or minus is based on the location. It does not mean both. Okay? So let's look at why they work part we're going to go over in class, so that part of your note guide you can skip. For example 1, to prove this identity, okay, I'm going to go ahead and do this. So we're going to prove, I guess, why one of them works, the tangent identity. I'm going to start on the left side, and where it says tangent of 2 theta, that would be the same as tangent of theta plus theta. Okay. Now I can use the sum formula that was in our previous notes, and that would mean that this is tangent of theta plus tangent of theta over 1 minus tangent theta times tangent theta. And if I simplify that, that's 2 tangent thetas in the numerator over 1 minus and tangent squared theta in the denominator. So that equals what's on the other side and proves using one of our previous identities that this is true. Another way that we would use this is with this calculation to find the exact value of the sine of 270. Now, I know you guys know the sine of 270. It's negative 1. I already know that. I want to show you guys how we would use the double angle identity. Okay? So if you wanted to find the sine of 270, if you want to use the double angle identity, you want to think of 270 as 2 times something, okay? And so 270 is the same as 2 times 135. So in the formula, this is like your 2 theta. So the formula says sine of 2 theta is equal to 2 times the sine of theta, which is 135 in this case, times the cosine of theta, which is also 135. So this is 2 times rad 2 over 2 times negative rad 2 over 2. I think of that as 2 over 1. When I multiply this all out, I get negative 4 over 4, which is equal to negative 1. So again, I already knew this, but I want you to understand this manipulation and rewriting, that rewriting 270 this way allows us to use this new identity, but it should work out to be the same thing. It's a different way to do this calculation. All right, here is another verify the identity. I'm going to go ahead and start on the right side because I see some things that I could substitute in. And I'm going to rewrite every tangent as sine over cosine and hope that that helps me kind of combine all this stuff into one thing. So I have a fraction with a common denominator here. So I'm going to go ahead and rewrite all of these. So this is 2 sine theta minus 2 sine to the third power of theta, which is a little scary, over cosine of theta. Okay. Nothing here is recognizable, but I do notice that in both of these numerators, they have a 2 and a sine theta, so I'm going to try and kind of factor them out. Maybe that will help me. Maybe it won't. It would leave me with 1 minus sine squared theta. Okay. So that's a little bit comforting, okay, because I know that 1 minus sine squared theta from our Pythagorean identities can be written as cosine squared theta. And now I have a common factor in the numerator and denominator. So I am left with 2 sine theta cosine theta. And from our double angle identity, I know that that is the same thing as sine of 2 theta. Okay? So that proves to be true. All right, so the tangent of 195, and we're going to use half angle identity. So I want to calculate the tangent of 195. But I want to think of 195 as some different angle measurement divided by 2. So if you're having a hard time figuring this out, 195 is the same thing as something over 2, and then solve this little mini equation. That's something that I want to put on top of the 2. 390. And then according to our formula, this is going to be positive or negative depending on what I decide based on location. And I would do 1 minus the cosine of 390 over 1 plus the cosine of 390. The cosine of 390 is root 3 over 2 because it's the same as 30. So this is 1 minus rad 3 over 2 divided by 1 plus rad 3 over 2. And now I got to figure this out. So I would first combine together this fraction. So I would think of 1 as 2 over 2. So my numerator here would be 2 minus rad 3 over 2. My denominator, I want to combine these together as well, so I will think of this as 2 over 2. This will be 2 plus rad 3 over 2. Inside the radical, I want to go ahead and do that division problem. So kind of off on the side, I would do 2 minus rad 3 over 2 is being divided by or multiplied by the reciprocal of 2 over 2 plus rad 3. And I'd get 2 minus rad 3 over 2 plus rad 3. That's all underneath the radical still with the plus or minus in front of it. If I want to rationalize this, okay, a little bit within the radical at least, I could multiply this by 2 minus rad 3, and then this by the same. You might see the answer written in different ways, so this is just one possibility. When you multiply out, here we basically have 2 minus rad 3 squared. And then in the denominator, we're going to have 4. The middle terms will cancel, and then we'll have minus 3, which will really just be like 1. So here we have this. So this part simplifies to be 2 minus rad 3. But I need to decide, is it positive or is it negative, this part right here. So you need to think, where is 195? So 195 is an angle that is more than 180, but not all the way to 270. So it is somewhere in quadrant 3. Would the tangent of something in quadrant 3 be positive or negative? It would be positive. So this is my answer, the positive 2 minus rad 3. All right, the last example we're going to look at in this section is if we are given that the sine of theta equals this and theta is here. So a picture of what's going on. Theta is an angle between 270 and 360. That tells me it is somewhere in this fourth quadrant, okay? But I would build the triangle for that angle here, okay? And I would use this reference angle. If the sine is negative 5 over 13 and sine is opposite over hypotenuse or y over r, this is what I have. But I can solve this right triangle and figure out that the other side is 12, positive because of its location. So now what they're asking me for is to find the tangent of theta over 2. So I'm going to go ahead and use my formula. So the tangent of theta over 2, look back at your formula, but remember to eventually have this memorized, is positive or minus. I have to decide 1 minus cosine theta over 1 plus cosine theta. So basically, I need to know what cosine theta is. So from my picture, adjacent over hypotenuse, or x over r, is 12 over 13. So for each of the cosine thetas here, I'm going to substitute 12 over 13. And just like in the previous problem, I need to do a lot of fraction manipulation and simplification. So I'm going to think of these ones as 13 over 13. 13 minus 12 is 1. So I get 1 over 13 in the numerator. In the denominator, I get 25 over 13. Remember what's happening here. 1 over 13 is being divided by or multiplied by the reciprocal of 13 over 25. So I get 1 over 25. And so this is plus or minus 1/5. Now I need to decide, is it positive 1/5 or is it negative 1/5? Well, think about where your angle was and if you cut that in half. So you had a statement that said 270 is smaller than your angle, but your angle is less than 360. If this is what's true about theta, you should be able to write an inequality about what is true when theta is divided by 2. If theta is divided by 2, and we did that to each side of the inequality separately, okay, and we don't flip the inequality unless we divide by a negative, 270 divided by 2 is 135. 360 divided by 2 is 180. So this is telling me theta over 2 is an angle that is between 135 and 180. So it is somewhere in here. Would the tangent of an angle in that range be positive or negative? It would be negative. So the final answer here is negative 1/5. So remember your formulas, and then we're going to do the why they work when you come into class and let you work on some problems as well.